So we have a radioactive material that decays according to the function. Here is the formula, where A naught is the initial amount and A is the amount present at time t in years. Assume that a scientist has a sample of 500 grams of that radioactive material. Now we need to answer a couple of things. So here the formula is given: A of t, amount left after time t years is A naught, that's the initial amount, e raised to negative 0.0244, that's the decay rate, t. Okay, now here decay rate is this. So negative means it's decreasing, so we don't have to mention for decay rate. That is 0.0244, which is same as, we can multiply by 100 and get 2.44%. Okay, so the decay rate is 2.44% per year. So in 1 year it decays in this rate, okay, because t is given in terms of years. So that's the context here. Now how much that radioactive substance is left after 10 years. So a scientist has 500. So initially this A naught is 500, by the way. This is 500. And how much left after 10 years? So this t is 10. So all we have to do is amount left after 10 years is A10. We have to plug in 10, A10 or 80, fine. 500 times e raised to negative 0.0244 t is 10 years. Now use your calculator and it comes out to be 391.744, and that in grams. Okay, because initial we had 500 grams, so this is also in grams. When will 400 grams of strontium-90 be left? So when we need to find the time, so same formula. So 400 is the final amount. 400 equals, initially we got 500, e raised to negative 0.0244 times t. So we're going to find this time t, starting 500 to get 400. So we need to solve this equation for t. For we divide both sides by 500. This is 500, so 400 over 500 equals, we have this e 0.0244 times t. This is pretty much 4 over 5. Now this t is in the exponent, we got e raised to. So take ln both sides, natural log both sides. Ln 4 over 5 equals, when we take ln, this one comes to the front and ln of e is 1. So it's gone, negative 0.0244 t. Now we divide by this negative number to isolate t. So t equals, so we have this ln 4 over 5. This is in fact a negative decimal number divided by negative 0.0244. I mean, you don't need to know whether this is negative or positive, but 4 over 5 is less than 1 and natural log of less than 1, but positive is a negative number. Now use your calculator, just punch in your calculator, you're gonna get 9.15 years. So everything is done in terms of years, so that's years. Now what is the half-life of strontium-90? Half-life, we use the same formula. We start from 500. Half-life means half of 500, that's 250. Or we can start with 1 unit and get 1/2, same thing. So it's already 500, so 250 equals 500 e raised to negative 0.0244t. Okay, here we found the time to get 400 grams. Now the half-life means to get to the half of original 500. In fact, we could have started with 1 unit and 1/2 here, which would be the same. Like we just solve like part C, divide by 500. So 250, 500, that's 1/2. Okay, 1/2. Now we take natural log both sides. So natural log of this is 1/2 equals, when we take natural log, this jumps, and negative 0.0244t times natural log of e, which is 1. Now we divide by this negative number to isolate t. That's the half-life. T equals natural log of 1/2, which is a negative number, divided by minus 0.0244. Now use your calculator and it comes out to be 28.4, that many years. Okay, final.